Hey there, welcome to Math 7, Unit 8, Lesson 9 on multi-step experiments. Let's look at probabilities experiments that have multiple steps. So first we begin with a true or false, and you're going to answer, is each equation true or false? Then explain your reasoning. So take a look at these ones as a class, and take a look at them and see what do you think, which one's true, which one's false, and then be ready to talk about why you think that is the case. So give a look at that one and see what you come up with. Okay. When I look at this first one here, for example, what I notice is that we're trying to get to a sum of 8 here, right? And I have 1, 2, 3, 4 eights divided by 3. Now, in terms of what we have here, this is 32 divided by 3. Well, 3 doesn't go into 32 evenly, first of all, but most importantly, I want to get to a sum 8 as my answer. Now, if I had happened to have 3 of the 8s, then I could do 8 divided by 3. And then at that point, or 8 plus 8 plus 8 divided by 3, because I'm dividing the 3 eighths up, and that would leave me with just 8 left over. So that would work, but this extra 8 right there messes up quite a bit. Take, for example, this one here. Here I have 10, 10, 10, 10, 10, which is 10, 20, 30, 40, 50. That's like 50, and again, divided by 5. Well, 50 divided by 5 is actually equal to 10. So this one is true and makes sense, unlike this one, which I don't have the right number of 8s there. Now, when you look at this one, it's a little bit different because here we have 6 and 4, 6 and 4, 6 and 4 divided by 6. Okay, so I don't have 5 groups of 6 here. I have this little mess. I have 10, 20, 30. Well, I could think of this as also being 6 and 4 is the same as 5 plus 5. So think of it this way. I could change all these 6 and 4s to 5 plus 5, and now I have 6 5s, and when I divide it by 6, I'm left with just 5. Or if you want to think of it this way, this is going to be 30 divided by 6, which is equal to 5. Again, just a little warm up there, true and false. Get you thinking about some math stuff today. Alright, so activity number 2, spinning a color and a number. It says the other day you wrote a sample space for spinning each of these spinners once, which we did, red, blue, green, and white, and the numbers 1 through 5. So what's the probability of getting a green and a 3, blue and any odd number, and any other color than red, and any number other than 2? To do this here, we'd want to have a sample space to be able to notice what we have. Overall, I know that I have 4 options here, and I have, or 4 possibilities here, and I have 5 possibilities here, for a total number of outcomes being 20. I have 20 outcomes that are possible in my sample space. Okay, that's my sample space. I have 20 outcomes. So if I write these out as a, write the sample space out, right, and list this out here, I can list this as, I can list red, I can list blue, I can list green, and W, and I have 5 of each one, so I can go 1, 2, 3, 4, 5. Go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And write the numbers here so I know what my options are going to be. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So this is my sample space, and these are all the possibilities that I could have for these spinners. Right? I can spin a red and then get a 1, 2, 3, 4, 5. And those are my 20 options. So what's the probability of getting green and a 3? Well, the green is here. So I have one of those, and the 3, I have this one right there. So there's only one of those in the whole mix. So the probability is 1 out of the 20 outcomes right there. Okay? So that's how that one works there. 1 out of 20. How about blue and any odd number? Well, here's the blue right there, and my odd number choices are the 1, the 3, and the 5. So I'd have to get this and those, and I see that there are 3 of those altogether, again, out of 20, right? So that's what I have. I have 3 out of the 20. Interesting, right? Okay, so we know we had 1 out of the 4 to start with, and then I had 3 out of the 5 to start with. Interesting. So I had 1/4 in this opportunity, 3/5 there, and I said that my total probability was 3 out of 20. Let's see the next one. Any color other than red and any number other than 2. So any color other than red. So we have blue, green, and white. So I have 3 out of a 4 chance for any color other than red. And then of those, any number other than 2. So I have 1, 2, 3, 4, 5, 6, 7, 8. And then I have 9, 10, 11, 12. I have 12 of those out of, well, in total I have 12. So let's leave it like that for now. I'm going to come back to that one here. So I know I have 12 there, and I can see that I have 12 possibility, right? So I know I have 12, just counting up normal style here. Ignore that for now. So when I look at the 3 colors, blue, green, and white, I have 12 that match those as well out of the whole 20 altogether. So to back it up or go forward here, that meant that of the colors, I could choose 3 out of the 4, and out of the numbers, I could choose 4 out of the 5. Right? This is my colors, and these are my numbers, 4 out of the 5. I have 3 out of 4 options there, 4 out of 5. When I multiply those together, what happens? I get 12 out of 20, which matches that. So let's back up to our very first one, green and 3. How many of these are green? 1 out of the 4 is green. How many of these are number 3? Well, 1 out of the 5 are 3. So when I multiply those together, what do I have? I have 1 out of 20. So when I'm combining probabilities, and I use this word and as well, tends to be kind of a key word here, this thing and this thing, I can multiply each one of the fractions together to find out what the probability is going to be, and I can verify that by utilizing the sample space. Let's do some more activities here together. Alright, activity 3. The other day you looked at a list, a table, a tree that showed the sample space for rolling a number cube and flipping a coin. Right? The number cube was 1, 2, 3, 4, 5, 6, and flipping a coin we had heads and tails. Your teacher will assign you one of these 3 structures to use to answer these questions. Be prepared to explain your reasoning. So let's say, for example, I'm going to just draw one real quick here. I'm going to go the 1, 2, 3, 4, 5, 6. So I'm going to make a table here. And I'll go heads and tails. And here we go, like so. So we have heads and a 1, heads and a 2, heads and a 3, heads 4, heads 5, heads 6, followed by tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So in total, how many outcomes are there? Well, we know that there are 6 outcomes for the cube, and there are 2 outcomes for a coin, heads or tails, for a total of 12 outcomes. So let's keep that in mind as we look at what's next. So what's the probability of getting tails and a 6? Well, we can look here and see that my tails are here, and in this row, the one that pairs up with tail and 6 is simply the 1 option right there. So we would say that there is a 1 out of 12 chance. Now, going back to what we said before, what's the possibility of getting tails? Well, that's a 1 out of 2 chance. And the possibility of getting a 6 is a 1 out of 6 chance. Right? So if we multiply those together, tails and the possibility of 1/6, we end up with 1/12, which matches our probability right there. What's the probability of getting heads and an odd number? Well, our probability of getting heads is 1 out of 2. And the probability of getting an odd number is 1, 2, 3 out of 6. So, based upon our number way of doing it, we should expect that 1 times 3 is 3, and 2 times 6 is 12. I should be able to find 3 heads and an odd number. And in fact, here's heads and a 1, heads and a 3, heads and a 5, and there are indeed only 3 of those possibilities. Okay, so that's the idea with that one right there. Okay, pretty fun. Now, suppose that you roll 2 number cubes. What's the probability of getting all these things? So now we're going to roll 2 number cubes. So let's make a new table. Make a new table. I'm going to go with a 1, 2, 3, 4, 5, and 6. And we're going to use it for different reasons here, so hang on to a second. 1, 2, 3, 4, 5, and 6. And we go like this. Alright, so here's our table for two number cubes, 1 to 6, 1 to 6, right? Alright, so what's the chance of both cubes showing the same number? Well, that's going to happen when you roll a 1 and a 1, which would take place right there, a 2 and a 2, which would take place here, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. Now first of all, before I get there, let's back up here. When we talk about probability, we want to know all the outcomes. Now the outcomes of rolling a 1 to 6, there are 6 outcomes for the first cube and 6 outcomes for the second cube, for a total of 36 possible outcomes, right? So when we look at how many would show the same, we have 1, 2, 3, 4, 5, 6 of those out of 36 outcomes. How about exactly one cube showing an even number? So not more than one, just one. So I'll put the little check mark here. So if we go down the even column here, I can do 2 and a 1. Can't do 2 and 2, that's even, even odd, even odd. Let's go to the 4. 4 and 1, 4 and 3, 4 and 5, 6 and 1, 6 and 3, 6 and 5. Now let's use the 2 here. I can get 2 and 1, 2 and 3, 2 and 5, 4 and 1, 4 and 3, 4 and 5, 6 and 1, 6 and 3, 6 and 5. So how many check marks do we make there for ones that show exactly one cube and even? I have 3, 6, 9, 12, 15, and I have 18 all together. So we have 18 out of 36, just looking at what we have there. Now again, I'm counting those all up. Is there a faster way of doing that? Well, if we want to think about one cube being an even number, okay, then I got to think that, well, with my cubes, I have even numbers here, right? I have 3 out of the 6 are even there. And then I have 3 of the 6 over here, even numbers. So that's going to be a little tricky because that doesn't quite work out the nice way, does it? So hard to do that one exactly. So how about at least one cube showing an even number? So at least one cube showing an even number. So we know we have all those check mark ones still. Those are going to be there. But I also can have the ones that then double up. So I can have the 18 I started with, but then I can include 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, and now all my evens are all filled up, 27 like so. So we're going to say it's 27 out of 36. And all I did there was add up, include the ones that have 2 even numbers there, because that is at least one. How about two values that have a sum of 8? So things that add up to 8. 6 and 1 adds up to 7, so I have nothing with the 6's, but how about 5? 5 and 3 is 8, right? Oh, sorry, not 6 is 6 and 2 is 8. So back up there a little bit. Whoop, too late. 6 and 2, 5 and 3, 4 and 4 is 8, 3 and 5 is 8, and this 6 and 2 is 8. So how many ways can I make 8? 1, 2, 3, 4, 5 different ways. Again, out of 36. Alright, and our last one, two values that have a sum of 13. Well, the largest sum I can get is 6 plus 6, and 6 plus 6 is 12, so I can't get to 13. So what's the probability of getting that? The probability is 0. Remember, probabilities are between 0 and 1. Those are our options. These are all fractions, and they all fit in between 0 and 1. So the probability of getting a sum of 13 is 0. You don't have to write 0 over 36. Yeah, you could write that down, but probability is just 0, so we leave it like that. Okay, number 3. Jada flips 3 quarters. What's the probability all 3 will land showing the same side? So we're talking about, we did this before, having heads, heads, and heads, and then maybe tails, tails, and tails. So we could have heads, heads, heads. We could have head, heads, tails, head, tails, heads, tail, head, head, right? That's the one tail. We could have heads, tail, tail, head, let's see, tail, heads, tail, and we get a tail, tail, heads, and we can also tail, tail, tail. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8 options there. All right. And why do I have 8 options? Because with the first coin, coin number 1, coin 2, coin 3, I have 2 things it can land on, 2 it can land on the second, 2 on the third. 2 times 2 times 2 is 8 options. So there are 8 outcomes for this experiment, and there are only 2 times in which I can get all of them to be matching. So in terms of a probability, it's 2 out of 8. The probability of all 3 coins being heads or all 3 coins being tails. Alright, let's look at one more. This is an optional activity that you may have done or maybe didn't do in class today. Pick a card. So imagine there are 5 cards. Alright, 5 cards. And you have red, yellow, green, white, and black. You mix up the cards, you select one without looking, then without putting that card back, you mix up and select another one. This is a different one to look at today, which is why I wanted to do it. I don't always do the optional ones, but today I am, because here we're not putting the card back. That means that on the first pick, how many options are there? There are 5 cards. On your second pick, how many options are there? Because you didn't put one back, there are only 4 options now. So 5 times 4 is going to give us a total of 20 possible outcomes. Got that? Not 25. Let's see our sample space and see how that works out. So we'd have red, we'd have yellow, we have green, we have white, and we have black. And then, when you're not putting them back, we only have 4 possibilities. So we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So if I get red, my next options, because I can't draw red again, are going to be yellow, green, white, and black. If I get yellow, then my choices are red, green, white, and black. If I get green, my choices are red, yellow, white, and black. If I get white, I can choose then a red, a yellow, a green, and a black. And if I get black, I can choose red, yellow, green, and white. So I can see 4 groups. I have 5 groups of 4 here for, again, a total of 20 outcomes are possible. So that's my 20. Okay, again, it's 5 times 4 for 20 possible outcomes. So what structure did you use to write all the outcomes? Well, for me, I use a tree in this case there. Could you have done it differently? Absolutely. You could do it differently. I just chose that one because I wanted to visually just look at it there. Okay? So now using that tree, let's answer some questions. What's the probability that you get a white card and a red card? Well, the first one, the chance of getting a white card is 1 out of 5. And then getting a red card, well, what's left down here, I'm going to have the option of 1 out of 4. Well, I'm not putting it back. And because I'm not putting it back, it changes things just a little bit here. So I can get the other card there. Now, the red card, I can see the red card happens a lot more times. I have the red card happening in 1, 2, 3, 4 of these things, don't I? Right? So I have it happening in 4 of these opportunities here out of the, in this case here, in the 4 groups, 4 out of 4. Okay, because 4 is the number of options I have left. Okay, so we would say then that we have 4, nope, sorry, let's back up here. I'm trying to complicate too much. Let's just do it the simple way. Let's keep it simple. So sorry. Let's go here. So the white card. If I get a white card and then a red card, let's just look at it. If I get a white, the chance of me getting a white and a red is I have 1 chance of doing it there out of the 20 outcomes. Or I can get a red and a white, which is 1 chance of here out of 20 outcomes. So in either order, it doesn't matter, I have 2 ways of getting that out of 20 possible ways. How about getting a black card either time? Well, the chance of getting a black card in the first one is going to be here, right? So I can see I got 1 black card there, no problem. And then I have how many other ways I can get a black card? I have 1, 2, 3, 4, there. So black card either time, I have, in this case here, I have 4, and I have one, and I can't think real quick. Black card either time. My notes are not making sense. Okay, so the odds of getting, probability of getting a black card either time. Well, first I have probability of getting it, first time I have 1 out of 5. And then my odds of getting a black card I have, that's already gone, is 1 out of 4. I'm gonna hang on one second. Okay, I see. Sorry about that. So here's what I'm thinking. This actually is not just 1, right? This is a black card, so it's 1, 2, 3, 4. And then I have this black 5, 6, 7, and 8. I forgot this counts as 4. So I have a total of, 8 possible ones out of 20. How about the chances that I do not get a black card either time? Well, that will be what's left over. If I can get a black card 8 out of 20 times either time, that means that what's left, the not, is the opposite of that, 12 out of 20. Okay, what's the probability? Again, probability is between what numbers? 0 and 1. What's the probability you get a blue card? Do you see blue as an option? I do not. So the probability of a blue card is simply 0. What's the probability you get 2 cards of the same color? Well, because the rule is you don't put it back, it won't be there and be available, so the probability is still 0. What's the probability you get 2 cards of different colors? Well, that's how this works. You always will get that. So while you could write 20 out of 20, because every one's going to be a different color, that would not be the best answer. The best answer is going to be 1, because probability goes from 0 to 1. That's the idea. Okay, so let's take a look at our summary real quick. So suppose we have 2 bags, and one contains 1 star and 4 moon blocks, the other 3 stars and 1 moon block. If we select 1 block at random from each, what is the probability that we will get 2 star blocks or 2 moon blocks? And so you can make a little chart here. Here's a tree diagram that shows you star, moon, 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 moon for the first choice, using the first bag there. In the second bag, we have 3 stars and a moon, and you see star, 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 moon, star, 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 moon, all the way through. So in highlighting which one's the possible outcomes, you can see that you can get 1, 2, 3 of them there. There's another one here. Here's 4, here's 5, here's 6, and here's 7. So we can see that there are 7 different ways of getting these outcomes. All right, let's take a moment to pause there. We'll work on homework and check in a second. All right, taking a look at your homework here. It says a vending machine has 5 colors, white, red, green, blue, and yellow, of gumballs, and an equal chance of dispensing each. A second machine has 4 different animal-shaped rubber bands. Okay. Lion, elephant, horse, and alligator. And an equal chance of dispensing each. If you buy 1 item from each machine, what's the probability of getting a yellow gumball and a lion band? Okay, you could write this out if you wanted to and draw the sample space, white, red, green, blue, and yellow, right? And then you can say you have 4 different animal choices, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And each of them have the lion, the elephant, the horse, and the alligator. So to get a yellow lion band, there are 1 of those in the whole thing, and that's 1 out of how many? Well, again, we have 5 colors and we have 4 animal shapes, so 5 times 4 is 20 possible outcomes. So we know there's 1 out of 20 chance of getting a yellow gumball and a lion band. The numbers 1 through 10 are put in one bag. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The numbers 5 through 14 are put in another bag. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, when you pick one number from each bag, what's the probability you get the same number? Well, these are the numbers that seem to be the same. 5 to 10 are the same numbers. So the chance of getting, well, how many outcomes are there going to be? Well, there's a 1 in 10 chance of getting anything in the first one, a number in the first one, 1 in 10. And then over here, there's a 1 in 10 chance of getting another number, right? You're going to pick 1. So it's a total of 100 possibilities there. Okay, sorry, there's 100. Sorry, ignore the ones. There are 10 options here and 10 here, which means there are 100 outcomes. Got it. And 100 outcomes. Now, of those, how could you possibly get the same number? Well, we can see a 5 and 5, 6 and 6, 7 and 7, 8 and 8, 9 and 9, 10 and 10. So there are 5 different combinations that, or sorry, 6 combinations, 1, 2, 3, 4, 5, 6 combinations out of 100 that would have the same number. Okay? Is it possible? It's possible, but really, really small, 6% chance. So if you wrote that probability as a decimal, you could write 0.06, in case you're wondering. All right. When rolling 3 standard number cubes, the probability of getting all 3 numbers to match is 6 out of 216. Wow, how's that possible? Well, remember, there's 6 numbers in the first cube, times 6 on the second, times 6 in the third, for a total of 216. Okay, so the chance of getting all 3 numbers to match, right, is going to be very, very, very slim. Okay, there's a 6 out of 216 chance that that's going to happen. Because again, think about it, you have 6 different numbers, so it can come up 6 different times. Now, the question here is, what's the probability that all 3 numbers do not match? Well, if the chance of them all matching is 6, right, that's all matching. That means all the rest are not matching. So 216 minus 6 is how many are not matching. So that's going to be 210 out of 216 as a probability. All right, for each event, write the sample space and tell how many outcomes there are. So we're going to roll a standard number cube, then flip a quarter. So we have the numbers, well, we can either write, you can write it down as 1, 2, 3, 4, 5, and 6. And then you can flip a cube, heads, tail, flip a cube, flip a quarter, heads, tail, heads, tails, heads, tails, heads, tails, and heads, tails. For a total of, let's see here, 6 times 2 for 12 outcomes. The next one, select a month and then the year 2020 or 2025. So we have January, February, March, April, May, June, July, August, September, October, November, December. And then we have 2 months apiece, or 2 years apiece for each month. And I'm just going to write it as a 0 and a 5, 0, 5 for the last digit, just to save myself some time. There's my sample space. And so sample space, how many outcomes are there? Well, there are 12 months, and there are 2 years, for a total of 24 possible outcomes listed out like that. And you could write them all. You could write January 2020, January 2025, February. It's just a lot of writing, and I chose to do the tree just to save some space. Finally, on a graph of the area of a square versus perimeter, a few points are plotted. Add some more, and then let's see what we got here. So we're talking about a square. So if I have a square with a side length of 1, that would mean its perimeter is 4. Okay, 4. So perimeter is 4. And area would be 1 times 1 is 1. So 4 and 1 is there. If I have a square with side lengths of 2, then the perimeter is going to be 2, 4, 6, 8. But the area is 2 times 2, which is 4. So we go 8 and 4. If I have a square with the perimeter and side lengths are 3, I have 3 times 4, which is going to be 12, but the area is 3 times 3, which is 9. So plot that right there. And the 4 is already done, so is the 5. So what's happening here? Well, we can see that this is going up like that, in that fashion. Is that a line? No, that is not a line. This is curved. So because it's curved, it is non-linear. And because it's non-linear, that means that it is not proportional. It has to be in a line. Okay, it needs to be in a line, and it needs to go through the origin. In this case here, this is not meeting that criteria. All right, that's it for today. Have a great day, and we will see you next time.